All right, awesome. Welcome, everyone. It's an absolute pleasure to be here. I know you guys came for a presentation that was titled something different, but I promise this one is better. It was just a little bit of a communication issue. I kind of want to start with giving you an introduction into the world of policy as code. But most importantly, I want to start off with introducing and talking to you about authorization. Now, who in this room here knows the difference between authentication and authorization? I know they sound very similar. Okay, we've got a few hands going up. That's great. Awesome, awesome. So essentially, there is a whole principle of just the concept of understanding permissions. As we're building out software these days, it's really important that we handle permissions correctly. So it's really important that we know that the right user can perform certain actions on certain resources, and we have to restrict their access, whether they can or cannot do certain things. And in order to enforce those permissions, well, we have to write policies and we have to write code that will reflect the rules that we want to implement. Now, there is a big difference between understanding permissions and actually solving permissions. Now, even though you might think you understand permissions very well, the case might be that when you actually come to build your own solution, something homebrew, something that you think will work, you'll end up that actually it might not be the case. The solution that you might have might seem like it's perfect at first and everything will work, but then suddenly your company will start to grow. You'll get more users, you'll get more granular permissions, and you'll be like, well, that doesn't work anymore, and you have to rebuild it. And then you rebuild it again, and you think everything is perfect, and then suddenly more requirements come in, and it doesn't work anymore, and you have to rebuild it again. So access control is what we call essentially dealing with permissions and controlling the access a user has into your application. Is hard. It's very hard to implement, and it's a struggle that many huge companies around the world have, and it's something that has become very prominent these days. If we sidetrack about 6 years ago, we've all been focusing on authentication, making sure that a user is who he claims to be, and we identify them. And that was the main principle. And actually, even before that, we all used to build our own solution, and suddenly all these solutions came into play, and we ended up utilizing them. Things like Auth0, things like AWS Cognito, things like Keycloak and Clerk.dev. There's a huge amount of SaaS solutions out there that we implement, and we never really think of building it ourselves, right? It's very, very difficult. Why would we do that when we can dedicate our time to doing something better? And same thing with authorization. It's increasingly becoming more substantial to implement within our applications, and it's hard, and we try and find ways to do that. So access control is hard, and there's certain things that we need to bear in mind when we're building access control. First of all, we started to move away from monolithic architectures, everything being in the same code base, everything interacting with each other, to a microservice architecture. So the things, how we separate our code, how we build our code, and making sure that it's sufficient and it's reliable. Now, there's many different scenarios, for example, with microservices and how we manage them. And then, of course, there is the use cases that we need to adhere to. Now, use cases keep changing. Permissions become much more granular. You start going from building simple admin and not admin, which you might understand as the basic principle of what a permission might be, to implementing things like RBAC, so row-based access control. Then ABAC, attribute-based access control. Then things like reback and building tenancy and multi-tenancy, and it just gets really, really complex, and it's very, very hard to handle. Then finally, we also have various departments, so challenging our solutions. So we might be building some permissions for an engineering department, and we think all is good, and then suddenly HR comes along, and they're like, well, no, we need this to be implemented as well. We need this user to access something else, and suddenly you need to go and change it. Then you might have sales saying, well, I need access to the banking information, but others do not. So you have to rewrite your solution. And then finally, minor bugs. Well, that's the most devastating thing that could possibly ever happen. An engineer makes a bug, the policy, the rule is written incorrectly, it might pass the test, but it still might be incorrect, and suddenly someone within your system gets access to sensitive information. Now, if you're working in healthcare, or if you're working in fintech, so banking, that could lead to really, really, really bad results, and you definitely don't want that. So, what is the best way to implement permissions? And we need to talk about here specifically about policy as code and how we would implement it. Now, let me share a very typical use case with you that we very often find that companies implement and suddenly they start to struggle. So you have an engineer, and he's working on some new software that he needs to develop, and obviously that software requires those permissions to be in place. And he goes in, and they're like, okay, well, we have more users to be added, so I'm just going to add an administrator role, and then everyone else is just going to be able to do whatever they want. Great. And then more requirements come along, like I've mentioned previously, and suddenly they're like, well, I need to add another role because I need to give someone a little bit more permissions than the previous administrator. So we add a super admin role. Now, what is the problem of adding a super admin role? Well, it's essentially like putting a band-aid on a broken foot. It's just not going to work. It might seem like you're fixing the issue, but it's not going to work. And then you have that developer wake up on a Monday morning and he's like, well, I'm going to go into work and today I'm not going to have any problems. And suddenly he logs into Jira, he looks at his Jira ticket, and he has to add another 60 new roles and 100 new resources, and he's starting to pull his hair out because it's just so much work and he doesn't know how to do it. And then he creates a PR, the PR doesn't work. Then his CDO shouts at him because he hasn't written any tests, and then he has to go back and redo the whole thing again. And that's something that we definitely don't want. So how do we prevent all of that from happening? And that's your engineer finding out that everything went wrong. All right, just a short introduction about myself. So I'm Filip Grebowski. I am a developer advocate at Permit.io. Permit.io is a full stack authorization as a service. So we provide a no-code solution to manage authorization. I'll talk a little bit about that later. I'm also a YouTuber. You might have seen me before or not. And I'm also a podcast host. So if you want to listen to some DevOps stuff, I highly encourage you to do so. Anyway, what is policy as code? Well, actually, the description of this is fairly self-explanatory. It's defining and managing policies using code, right? So there are a lot of benefits that are to do with policy as code, or in short, PAC, as we call it. And the first benefit of implementing this sort of structure, especially when you're dealing with microservices, so decoupling that policy from your code. And there is a lot of benefits of making sure that that code is separated from everything else. First of all, it will be very easy to manage the code. It will be very easy to update your policies. There will be a separate policy for each microservice, so you won't have to worry about any overflow or any conflicts that come along. Having anything as code these days is very relevant because you can use tools and processes to manage that code in the way you would want and in the way you would use your other code and other software to manage those tools and processes. And of course, a very important thing is that with any decoupling of code and storing code somewhere else, well, you can track the changes, you can roll back the changes, you can version it, and you can do a simple review on it as well to make sure that everything that's going out is right. Now, benefits, another one, increased flexibility. So with policy as code, there is many policy engines that allow you to run that code. So a policy engine takes the code that you've written and it evaluates the rules. So it can understand the rules and it then returns to you an answer whether it agreed to let someone proceed within the system or not. Now, of course, with policy engines, there's many policy engines out there, and there's also many policy languages out there that you could use. And decoupling that policy and making it as a policy as code structure, well, it allows you to stay away from the code that you might be using to build your own software, and you can use just some other language that suits your needs best. So it really allows you to adjust and make sure that you have the best tool for the job. Finally, improved performance. Now, this is a really important one because usually when people decide to build authorization and they decide to create something that checks for that user, well, they'll write it all in that single code wherever they're doing it. Now, you don't want to do that because it will essentially affect the performance. What you really want to do is, as you do the policy as code and as you decouple the code, you're separating that code away and essentially improving the performance of your application because you don't have to perform that evaluation of that code on the spot. You just do it somewhere else and have a dedicated policy engine to do that for you. Now, best practices. Are there any best practices with writing policy as code? Are there any best practices with making sure that we use policy as code? Well, recently, there has been a change, and as we see, technology is evolving a lot, and we see a lot of changes come along. And there's two main changes that kind of expedite the process of developing software for any engineer. The first one is working with no-code solutions. to really improve the performance, the speed of when an engineer has to make a change or do something within his software. And the other one is infrastructure as code. Anyone heard of infrastructure as code here? Okay, a lot of hands up. Cool, great. So infrastructure code works really well with the concept of GitOps. Now, infrastructure code is essentially separating the code into specific chunks and making sure that we can use the same tools that we'd use for any kind of automation or any kind of thing that we work on when we're essentially evaluating our code. Now, I assume everyone here is familiar with Git. They've used Git. They're using Git. They've played around with Git. It's very, very fundamental to use Git as a tool nowadays when we're developing software for everything, from code review to versioning to making sure that we can roll changes back, like I mentioned, to decouple code. And GitOps is essentially becoming a very popular and almost a de facto way of doing certain things, especially for policy as code. Now, GitOps allows us to have those policies when they are generated by the policy engine, and when they're written by the engineer, you can push them into Git and you can track all their changes. Now, GitOps is essentially a way of allowing us to serve and have the policies we write as a single source of truth when we do compare against for any authorization policy and any authorization enforcement. So we need policies to be able to interpret that code. We need to be able to understand that code and make the right decisions. Now, there is many policy engines that are out there that we can use today. There is OPA, Open Policy Agent. Who heard of OPA? Who's used OPA? 2 hands up. Not many people heard of OPA. 3 hands up. Nice. So OPA is the Open Policy Agent. It's a CNCF project that has been adopted. So it also almost stands as the standard for writing authorization and using the policy engine to evaluate your authorization code. Now there is OSO, which is another policy engine. And finally, Cedar. This is a very, very new one. It only came out 2 weeks ago. It's backed and created by AWS. And essentially, it provides you with another language and another policy engine to write those policies. Some say it's much more performant. Some say it's easier to use. I'll show you some examples later on the slide so you can see for yourself. Now, are policy engines in some way limiting? Well, we have a bunch of policy engines that we can use, so we're not limited by the selection that we can pick from. But the policy engines are actually, well, are they limiting us? And the answer to that is yes. Unfortunately, they are. So let's talk about OPA. I'm going to use OPA as an example to tell you why we are limited and what has happened in the world of OPA. So OPA is an open source project, so it's available to everyone to use. And essentially, it allows us to reinvent how we enforce permissions. And it's been battle tested by a lot of big companies like Goldman Sachs, like Pinterest, like Netflix. So a lot of huge companies are actually using OPA in their own infrastructure to manage authorization. Now, when is OPA not enough? So I'll give you 2 very, very simple examples of scenarios that you might come across that maybe you never thought of existed that we have to pay attention to. So imagine a scenario where a certain user A has permission to some resource X, and they need to perform actions on it. Now, suddenly, someone doesn't like that person on the team anymore, and they revoke their permissions. So they're like, yep, you're not allowed to access this anymore. But because they're using OPA on its own, that user still has access. Why? Well, the problem is that when you provide that access, when you revoke that access with OPA, that policy doesn't update in real time. So the old policy still stays the same. OPA or any other policy engine doesn't have that mechanism to update those policies in real time. It only has the mechanism to be able to evaluate the policies, but not update them. Another example, and this one was to do with Netflix. Essentially, they had a problem where they had people that subscribed to their service, and obviously at one point they wanted to pay for the service and they wanted to have access to all these different shows. Now, the problem there was that obviously, well, if they just used OPA, well, clearly they wouldn't be able to update those subscriptions in time. Someone would become a paying customer, and they wouldn't have that possibility of watching the shows because the policy would not be updated. And that's why I have Netflix here. Now, Netflix did something interesting because they used OPA, the open source project. They took it in-house, and they decided, well, we're going to build our own solution for this. And they did, and they developed a mechanism to track the changes within Netflix, so the changes to subscribers, subscribe to those topics, and suddenly feed the policy engine with the latest updates, and have OPA understand that those policies have changed in real time. So therefore, they developed this, and it worked perfectly. But there was a problem, and that's how it made us feel. The problem was that they never open sourced any of it. They just kept it internally. So yes, they might have created a great solution, but nobody else can use it. So you're still stuck with OPA, you're still stuck with this open source project, and you can't update policies in real time. So Opal to the rescue. Now, Opal is an open source project that we've built at our company. It stands for Open Policy Administration Layer. And essentially, at first, it might seem like it's relevant to OPA, but the reason it's called OPA is because it was just a marketing play from our side. OPA at that point was the main policy engine that was being used, and we just decided to do a marketing play on the word and call it OPA just for better adoption from the users. But now, obviously, there is much more policy engines out there, things like Cedar, who we also support. So Opal is essentially a layer that you put on top of your policy engine that allows you to track those updates in real time. So Opal allows you to specify a topic you want to subscribe to, a specific data source you want to subscribe to within your application. And then when it tracks a change and reflects and notices a change, it will take that policy that changed and push it directly into your policy engine, so your updates always stay in real time. Now, Opal, like I said, is also open source. So now we've essentially made this whole in-house system where any of you guys can suddenly build their own authorization solution without writing it from scratch, without writing your own policy engine, without writing your own policy language, and be able to implement really good authorization. Now, like I said, OPA is not the only policy engine. I showed you OSO and Cedar beforehand. But with every policy engine, there is a big problem. And every policy engine has its own policy language. Now, being an engineer, being faced with the task of learning another language, well, some of you might like it. If you saw what it would take you to work with a language like Rego or Cedar, which is, in effect, very recursive in itself, but also it's completely different to what you might be used to, well, it's not such an easy job. So usually when you have a whole department of engineers who are working with OPA and Opal, well, they only dedicate a few of them to learn the specific language for implementing those policies. Now, we have Rego code, like I've mentioned. Rego code is the code that's used for writing rules for OPA. Then we have Polar. Polar is another policy language used for OSO. And then we have Cedar. In some retrospect, it's called the same thing, the Cedar language that allows you to write the rules and policies for the Cedar authorization engine. Now, I'm not going to do a deep dive into all these languages and their benefits and which one you should use, because like I said, the whole concept of this is that you then decide which tool is best for you to use. But I want to outline the quick example that I've told you about when it comes to implementing policies and what they actually look like. So here's an example. This is an example of Rego code. Now, there's many different structures and policies that you can implement. In this case, what we're showing here as the code example is a very simple role-based access control policy, which means if I put it into words, a specific user X can perform this action on a resource. And in this case, you can see we have a user called Alice reading a document. Now, it might seem easy because it's a very simple role-based access control policy. But in general, Rego is very widely used and very supported, so that's the advantage of it. But it can be quite complex to learn. Now, it can be complex to learn because look at the way Cedar looks like. Now, as you're probably looking at it, it looks much easier to understand. It looks much easier to write. It doesn't have all that fluff around it with importing specific packages and making sure everything is written in that declarative way that Rego likes to have it. So it's definitely a language that's easier to understand, but it's not as widely supported yet because it has just been released 2 weeks ago. It is backed by AWS, so you're going to see a lot of this probably in the future. You're probably going to see a lot of articles written on this, and it's just a case of, like I said, finding the best tool that suits your needs. Now, policy as code is one thing, but then there is also something called policy as graph. Anyone familiar with it? No? Nobody? Okay, so in 2020, Google released a specific authorization system, and they called it Zanzibar, Google Zanzibar. Now, anyone familiar with it? Still nobody. Okay, well, amazing. I get to teach you something new. Google Zanzibar is essentially a policy as graph authorization solution. What does that mean? Well, typically when you write a policy, like I've explained to you, a policy has a user who has a set of rules which can determine what he can and cannot do. Now, with a certain normal policy as code, there is certain implementations and limitations that you might come across. For example, if you have tens of thousands of users, hundreds of thousands of resources, and millions of actions that you need to perform, well, it's going to get a little bit difficult. So this is where policy as graph comes in. Now I've got this picture from Google Zanzibar. Essentially, this is a picture of what a policy as graph solution might look like, and a simple representation of it. And with policy as graph, you've got things like nodes, which represent the resources that you're performing an action on. And then you have the edges, so the lines, which essentially represent the relationships between resources and users. Now, a user might have a relationship with a file if they are the owner of that file. So that's a very, very simple example. But obviously, with recursive code and recursive policies and recursive rules for authorization, things like that might get very, very complex. So a policy as graph solution is very nice to represent it visually and to make sure that it's actually a lot easier to understand. Now, there's two main advantages with policy as graph. It's much more flexible. What does that mean? Well, you can represent very complex relationships in a policy graph, which you might not be able to, or it might be very difficult to do with just writing your own policies as code. The other thing is it's much more scalable. What you can do with a policy as graph is you have the flexibility of being able to separate it into smaller subgraphs and then evaluate those policies on those smaller subgraphs. So suddenly that performance is much faster. You're able to traverse through the graph much quicker. And of course, it makes it a little easier to deal with such a big data set of users, resources, actions, different tenants, different groups, and it just continues going more complex and in depth. Now, I want to talk about something that's very close to my heart. It's something that we do work at Permit, and it's implementing no-code and low-code solutions into all the very complex cases of engineering flow. In this case, implementing authorization in the world. Now, from what I've explained to you, you might be thinking that, well, authorization is actually quite difficult. It's not as simple as I thought with just implementing 3 roles of admin, non-admin, and super admin. It gets much more complex than that, and having an engineer to write that code is very, very time-consuming. I'll leave this up, as I'll explain. This is an implementation of writing and implementing and generating policies as a no-code that we have built. Now, what's the benefit of doing this rather than writing your own code? Well, first of all, it takes away a lot of stress from an engineer to have to write a new language. I mean, think about it. You're coming up with this authorization solution. Suddenly, you have a whole engineering team that needs to implement this, and you need to find that one poor schlep of a developer who's going to be really unhappy about trying to learn a new Rego policy and a new language to implement this, and hope that he doesn't make any mistakes. That's the first thing. Secondly, we as engineers very often tend to be bottlenecks for creating specific solutions. And we wouldn't be the bottlenecks anymore because we're able to provide a solution that generates that code for you. So you don't actually have an engineer sit down and write the code. Now, the other thing is that you have flexibility with picking what language you use. With a no-code solution, you're able to take a policy like Rego, or then the next day you're like, well, actually, no, I don't want Rego anymore. I want to work with Cedar because I feel like it's going to be more performant, it has better support, and it's just going to work better for the overall company. And you can do that. It will work in the same way. It would be the case of just changing a toggle, and that policy would be generated in a different language. Now, the other great thing is authorization, like I said, is very, very hard, and the people that can only write it are the engineers. With a no-code solution, you're allowing other stakeholders. So maybe people that are less technical in your company, like your product managers, or maybe your people in the sales department, or maybe some people from the HR to be able to adjust those policies when they need to do so. Now, the other thing is, because when you're creating a policy here, the way we kind of designed it is that when you generate the policy, it directly gets pushed into Git. Now, obviously, like I said, Git has a lot of advantages along with it. So obviously, you'll be able to manage all that code in the Git repo. And for any scenario where we wouldn't probably cover about 15% of scenarios in this case of very, very complex, granular, recursive permissions, you're still able to access that code directly, and you're able to add on top of that code if you need to. So therefore, managing that policy is much easier. And of course, the final thing is that with a no-code policy, you're not just limited to creating RBAC policies, so role-based access control. You also have policies like ABAC and REBAC, and so on and so forth. Now, I'd love to show you a little quick demo of what the beauty of creating no-code solutions is, and how easy it is to do so, and how quickly you can actually change it. So let me just share my screen here. Okay. All right. So here we have a very simple to-do app. Now in this to-do app, we're logged in from an authentication provider. In this case, you can see right here at the very top, I'm logged in through Auth0, and I've just logged in as a normal user, and I've synced that user into Permit. And within Permit, I assigned that user a role of an administrator. Now, within this simple to-do app, we can deal with two things. We can interact with, if I just find my cursor, okay. We can interact with a task, so we can create new tasks. If I do so, like this. These are the resources. The task is the resource that we're working with, and you can define resources, whatever they might be. We can edit that task or change its name. So we can just do something else. We can check that task. However, as an administrator, if I go back and I'll try and delete a task, I don't have the permission to do so. So what would happen now? Well, now, in a normal typical scenario, you'd need to dedicate an engineer. You'd need to create a ticket for him. He'd need to go into the Rego code or Cedar code or Polar. He'd need to write the policy. He'd need to write tests for the policy. He'd need to check the policy, push it into dev environment, make sure it actually works with a project. Then, of course, if it does work, it would have to be merged, and that policy would get adapted and pushed into OPA or any other policy engine for it to actually take place and work within the web application. Now, in this case, if I go back into Permit, this is a very simple Permit no-code dashboard. You've got the role of an administrator here and the different resources that we're currently working with. Now, here we've been working with a task resource, and this is the beauty of Permit. It's as simple as checking the task that now you want to allow for that specific role to perform on that resource. You want to go ahead and save those changes. Now what happened now is that policy already updated in real time. It's already been pushed into the policy engine. So now, even without refreshing the page, if I go back to that to-do app, and I'll go ahead and I'll try and delete this specific task, well, now I have the permission to do so. So that permission already took effect, and it's as simple as that. And all that code and all that generated code is also available to you, so you can look further into it. Now, it doesn't just end there. There's also ways of managing ABAC policies, so more permissions, more granular permissions. And in the same way, I'll show you a very quick example in the to-do app in the demo. Here, for example, we have, if I type in US paying admins, there we go. So this is what we call a user set. So it's a role with extra conditions specified on top. And we have things like resources with extra conditions specified on top called resource sets. If I actually show you what those conditions look like, if I edit this row. Oh, that's the wrong row, my bad. And just go back to US paying admin. Oh, yeah, typo. All right, and if I edit this policy right here, I do this row. Why is it going back to the? Am I doing something wrong? It's weird because I have the screen here, so it's a little difficult for me to control it. Okay, let's go. US paying admin. That's the one. There we go. All right, and let's edit this user set. All right, okay, perfect, we got there. So what you can see here is that we have extra conditions specified. We're saying that the user role has to be an administrator. We're saying that the user location has to be located in the US and that the status of paying has to be equal to true. So now whenever that policy gets checked against the user, well, it will dynamically match with the requirements that you specified in that enforcement point. So now in this case, if I go back and I'll clear this and I go back to the admin role, in this some way we have here a resource set, and here we have a condition. There we go. Here we have a condition saying that resource checked is equal to true. And that's the condition that we're trying to meet. So in this case, if I just uncheck the previous policy that we've created and save those changes and update that Rego code again. Now, if I go back to the to-do app, what I'll be able to do is if I try and delete this task, well, I won't have the permission to do so. But now, as you can see in the application here, we say that if the task is checked, the delete is checked as well. So a user can check a task and delete it. And in the same way, now if I go back ahead and I'll check this task, and then I'll go ahead to delete it, it will work. Okay, so there is a very simple example of a simple RBAC policy and a simple policy generated with no code. Now let me go back to my presentation. Let's go back to the slideshow. All right. Cool. Now, what is the moral of the story? Well, what I've shown you today is some principles and some basic concepts that you should take into account when you're implementing any authorization system. It's very important that you establish the fundamental concepts from the beginning. It's very important that you don't go ahead and build your own brew solution because, for example, in our case, from most of the clients that we had and from most of the customers and people that we worked with, even though they had a custom homebrew solution that they think worked really well, they still ended up having to rebuild it again and again and change the way they apply their architecture. And the best way to go is to start by implementing a policy engine, start by using the open source projects, and then obviously if that requirement comes along, then maybe dedicate to moving on to a no-code solution. All right. Thank you very much. Thanks for listening. I hope you guys enjoyed that. I hope you guys found this presentation valuable. And I'm open to any questions.